hello and welcome to the second session of this second day under the chapter sets. Go and ask any student which is the easiest chapter in 10th class. 99% students say it is sets. So what I now say is, it is an easy ball to a batsman, and a good batsman never leaves a loose ball. A loose ball has to be converted into a six so as to maximize the benefit. So if you ignore a loose ball, you are really losing a lot. So please concentrate on this chapter. Though considered easy, it is not really easy if you ignore. And if you really concentrate a little bit, it is a boon for you. A loose ball which you can convert it into a sixer. Good luck. Coming to the 10th problem now. Draw the Venn diagram for A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 and U is equal to 1, 2, 3 and so on. When you have a number of elements, you don't write, just simply put on dash dash and finally write the last elements. So this is given and you have to draw a Venn diagram. What is a Venn diagram? The great scientist John Venn, of course, simultaneously in some other country, Euler also worked on the same, because a set is a fixed group and there are some elements in it, and anybody must be able to say what belongs to it and what not belongs to it. So they can be simply put inside a closed figure, they thought. So elements they started to represent using circles, triangles, squares and so on, the closed figures, but mostly used are the squares. So now let A be a set with these elements. Now we also have B with these elements. So how to write B? Should we write B here or how? Let us see that one. And we also have a universal set like this one. So universal set means to be drawn using a rectangle. So this is universal set. So inside this, all the elements from 1 to 10 must be there. No matter they are here or here or here, that does not matter. So before that, should they be apart from each other like this, or should they be mingling with each other a little bit, or should they be overlapping each other, or should they be lying in one inside the other? That is what we have to see. If you observe these, you will understand there are 3 elements common in both. Yes or no? So how can you write it? For example, if you write here 1, 2, 3 and 1, 2, 3 here, as we have just now discussed, they should not be repeated. If you are in India, you are said to be in the world, and if you are in the world, you should be in some country. So if you are somewhere here, you should be only in one country, not in both places. So this is not the proper method. Then how we can do like this? You can write like this. So 1, 2, 3. Now if this is written as A and this is taken as B, you see A has 1, 2, 3, but they are all present in B also. So we can consider 1, 2, 3 are present in B also. So besides 1, 2, 3, B has 4, 5, 6. These 4, 5, 6 lie like this. So this goes away. This is not right. Now 1, 2, 3, 4, 5, 6. So these are the elements represented. Now what about the other elements? This universal set has numbers up to 10, from 1 to 10. So 1, 2, 3, 4, 5, 6 are written. Then what about 7, 8, 9 and 10? They are not inside B. They are not inside A. So they are outside these two. Therefore somewhere here is here. So 7, 8, 9, 10. It's your choice, but inside the universal set. This is how we represent using Venn diagrams. For example, if there is only 2, 3 common in between these two, then what happens? Let us see. Here we will draw the same thing. The universal set will be there, and inside this, let us think this is A and this is B. First of all, let us think. Now this, what are common? You have to check between these two. So 2, 3 are common, so they must be written in between them. So for example, if I write 1, 2, 3 here, and I can't write 2, 3 here, so 2, 3 must also belong to this. So let us get this a little bit closer to this. Now let us make this one a little bit closer. So we'll get it a little bit closer so that they touch each other. Now this area belongs to both. If something is here, for example, let this be A and let this be B. If something is here, we say it belongs to A as well as it belongs to B. So whatever are common for both, you write them here. So we should always write the common elements first like this. So now what are present in A? 1, 2 and 3. 1, 2 and 3. 2 and 3 are already written. So we write 1 here. And what are there in B? 2, 3, 4, 5, 6. So 2, 3 are here. So 4, 5, 6 you write here. Now what are there in universal set? Up to 10. So 1, 2, 3, 4, 5, 6 are written. So 7, 8, 9, 10 will be somewhere here. So this is how we represent. Now here all the elements in A are present in B. So in this case A is called subset of B. Subset like this. A is subset of B. B has more elements along with A. So we say B is superset to A. Now coming to this problem, here both have some elements in common but not all elements like this. So here all elements of A are present in B, so A is a subset. But here some elements of A are present in B also, they only have some joint. So if some elements are common in both, we say they are joint sets. They are joint sets. For example, let us take some other sets like A is equal to 1, 2, B is equal to 3, 4, U is equal to 1 to 6. Now what happens here? Let us see. Now you will draw a rectangle for the universal set which would have numbers from 1 to 6. Now A has 1, 2. So before writing we always imagine whether they are, you imagine from separate things first. If they are common, you join them a little bit. If they are all common in one, you will get one inside the other. Now here 1, 2 are present in A. Let us think this is A and this is B. And 3, 4 are present in here. So 1, 2 whatever are present here are not present in B. And 3, 4 whatever are present in B are not present in A. That means there is no joint. So there are no common elements between A and B. So we call this kind of sets which do not have a single common element as disjoint sets. Disjoint sets. Now because there are no common elements. Now what about other elements? 6 up to 6, 4 are already there. So 5, 6 will come here. So now this is how we represent disjoint sets. So subset, joint set, disjoint set. Coming to the next problem, the 11th problem, find A union B if A is equal to 2, 5, 6, 8 and B is equal to 5, 7, 9, 1. And also draw the Venn diagram, he is asking. So now we have to find A union B. This is called union or the cup. So what is union? Union is nothing but the combination. So the combining. So if you combine all the elements of A and B together and write them, that set is called A union B. So how do we write this? So write A union B is equal to write the elements of 2, 3, 6, 8 union 5, 7, 9 and 1. Now combining them together, you write them all together. So 2, 3, 6, 8, 5, 7, 9, 1. Now finally we will write them together. If at all there are any elements repeated, you will not write them twice, you will only write them once. So let us take them in the ascending order so that it will be very much easier. Though it is not compulsory, it gives you a clarity. So 1, next comes 2, next comes 3, next 4 is not there, next 5, 6, 7, 8, 9. So now this is the union of A and B. Union of A and B. Now he has also asked to draw the Venn diagram for this. So how do we draw the Venn diagram? Simple, it is always the same. Universal set. Next, A and B. Do they have any elements in common? No elements are common. So you need not touch them. You can write them separately. Now what are there in this? 2, 3, 6, 8. 2, 3, 6, 8. Now what are there in this? 5, 7, 1, 9. Now here we don't use commas in the Venn diagrams. Now this is how we represent. Now if you have to draw, do like this. So A union B means what? all these together. So you will simply draw something like this, some lines like this, and say like this. So in this diagram, where there are such kind of linings, all that area is considered as A union B. That means all the elements present in this kind of lined zone come under A union B. So what are there in A union B? 2, 3, 6, 8, 5, 7, 1, 9. 2, 3, 5, 7, 6, 8, 9, 1. Yes, they are all covered. So this is how we write it. And how do we write set builder form for A union B? Let us see. So A union B has these elements. Now 1, does it belong to A or B? 1 has come from B. 2 has come from A. 3 from A. 5 from B. 6 from A. So like this, if you observe properly, all these elements belong to either A or B. Either A or B. So that we simply express like this. What is A union B? A union B is set of all x's such that x belongs to A or x belongs to B. X may belong to A or X. Both of them we will take together. That is why we use the conjunction OR. Please remember. So A union B is equal to X such that X belongs to A or X belongs to B. We also have another operation, the intersection, nothing but cap. So for example, if A has 1, 2, 3 and B has 2, 3, 4, 5. Now what is A intersection B? You see, as the name suggests, intersection, but that means the area in between them, the common area between them. So what is common between them? 2 is common between them, 3 is common between them. So the elements which are common between them are considered to be the elements of A intersection B. So whatever are common, we will write them together. There we were writing combining all in the union. Now here we are writing only common elements. So this is how we write it. Now how can we write the set builder form for A intersection B? Now this has all x's such that x belongs to A. Yes or no? But it also belongs to B. So x belongs to A and x belongs to B. There it was R for union because that may belong to that one or this one. But here it should belong to both and. So when I ask you give me red pen and blue pen, you will give both. But if I ask you red pen or blue pen, you will give only one, any one of them, not two. So in union that may belong to either that one or this one. That is the thing. But here it should belong to both compulsorily. And in union, it may belong to that one or this one, sometimes to both also, but that is not the compulsory condition. But in this, the compulsory condition is that it should belong to both the sets. Then how to write? Then how to represent it? Using Venn diagram. The same, we take universal set. You may doubt, sir, universal set is not given. Though universal set is not given, it is convention that you have to use a rectangle and represent universal set and only then draw the Venn diagram. Now what about A and B? Do they have anything in common? They have a part in common. So we will combine a part with each other as discussed earlier. Now what are there? The common elements we write first. 2, 3, 2, 3. So 2, 3 we write here. Now 1 is present, 1, 2, 3 are present in A. So 2, 3 are already there. So 1 will be here. In 2, 3 are here, 4, 5 will be here. So here there are no elements, no problem. So now, this is A intersection B. What is A intersection B? You haven't indicated is 1 or 2, 3 or 4, 5. Who knows it? Yes. For that, you have to again draw lines like this so that the elements are clearly visible. So now you will draw like this. So this is A, this is B, and A intersection B is that area consisting of this lined zone. The elements coming there are all a part of A intersection B. So what are the elements there? 2 and 3. So A intersection B is equal to 2 comma 3. The set builder form is A intersection B is equal to X such that X belongs to A and X belongs to B. Now the 12th question is find A minus B for any two sets A and B. Why should we take some other sets? Let us take the same sets. Now what is A minus B? Let us see. To tell you clearly, let us represent them in a Venn diagram and then make it clear. So how to draw the Venn diagram? The universal set then you see, please remember they should be closed. At any cost they should not be open. Now A and B have some common, so you write like this. So the common elements are 2 and 3. Now this is 1 and this is 4 comma 5. Now what is A minus B? What is A minus B? Let us see. A minus B is that from A, if you remove all the B completely, whatever remains in A is A minus B. So for example, you remove this B completely. Imagine it is patched. Now what can you see? The only one. So only one. That means the elements in this are all equal to A minus B. So that is how we represent. So like this. So the area with this kind of dotted lines and the elements in it come under A minus B. That means this one is equal to A minus B. The set consisting of only one element 1. It is called a singleton set. A set having only one element. It need not be 1, it may be 2, it may be 3. But number of elements is only 1. That kind of sets are called singleton sets. Right. Now, what if I have to do B minus A? What if I have to do B minus A? So if it is B minus A, what should you do? Let us see. B minus A means from B, take away A. A is not required. Take away A and write whatever is remaining. So now take away A, just patch it. Now what appears? 4 and 5. So 4 and 5 is equal to B minus A. So how to represent that? This is already dotted like this. So let us draw vertical lines like this. Now this vertical lines represent B minus A. So this represents A minus B. So if you are given 1, 2, 3 elements and asked you to draw, this is how we draw. If at all you are not given numbers and it simply asks you to draw A intersection B or A minus B or A union B, then how to do? If you are asked to draw A minus B, how to do that? So this is, you will always write them as joint sets, not disjoint or subsets. You don't write them as joint sets. Now this is A and this is B. Now A minus B. So B has to be taken away. B has to be minused. So take away B. What remains? This part remains. So this is A minus B. This representation is most important. Without this, this is meaningless. So this is one important thing. So if it is A union B, how do you do it? Like that. A, B, this is your set. A union B means all A and B together. So you will draw lines all through this. So this is A union B. Very simple. So you have to represent here like this. A union B is equal to like this. What about A intersection B? Let us see. You will draw this one. You will always take joint sets as discussed. So now A intersection B. Inter means in between. Section means area. The area in between them is this one. So A intersection B is equal to this one. This is very simple. So with numbers also you will do it. Without numbers also you must be able to do it. That's it. So what does A minus B mean? A minus B means they belong to only A and not B. You see, you have taken away B. Means only those elements belonging to only A are present. So how can you write it in set builder form? Let us see. So what is A minus B? It will have all x's such that x belongs to A only. X belongs to A only. But it does not belong to B, has been taken away, no? So and x does not belong to B. Then what about B minus A? So we write it as B minus A is equal to x such that x belongs to B. It belongs to B. So and it does not belong to A because A has been taken away. So this is how we write the set builder form for A minus B and B minus A. Now coming to the 13th problem. P is equal to 1, 2, 3 and 4. Q is equal to 3, 1, 2 and 4. He asked whether they are equal or not. If so, why? How do we decide whether they are equal or not? Simple. We will check in both the directions whether all the elements present in P are present in Q or not, and whether all the elements present in Q are present in P or not. Because it might happen like if you check in only one direction, all the elements present in it may be present in it and in excess also there may be some elements here. So you have to check it in both the directions. So we will check in the first direction. So the one present in P is also present in Q. So it is in the first place here and it is in the second place here. The order does not matter. All that matters is whether it is present or not. That's it. 2 that is present in P is also present in Q. 3 that is present in P is also present in Q. 4 that is present in P is also present in Q. Now all the elements present in P are present in Q. That means we can write it as P is subset of Q. Yes or no? All the elements present in P are present in Q. Therefore P is subset of Q. Now we will go in this direction. 3 that is present in Q is present in P. Yes. 1 that is present in Q is present in P. 2 that is present in Q is present in this one. 4 that is present in Q is present in. So finally all the elements present in this are present in that one. That means we can say Q is subset of P. Why? All the elements present in Q are present in P. And finally all present in here are present here and all present in here are present here. So can we say they are equal? Yes. But this is not right, saying all elements present in this are present in that and that are in this. This is not proper. So let us say it in mathematical terms. All the elements present in P are present in Q. That we express like this. So P is subset of Q. And all elements present in Q are present in P. Therefore Q is subset of P. Therefore we say P is equal to Q. So P and Q are equal sets. So when can we say P is equal to Q? When P is subset of Q and Q is subset of P, we say P is equal to Q. There is a small explanation about subset. What is actually a subset? A subset should have all its elements present in this one, but it should be smaller than this actually. In that case, that set is called proper subset. Here you see all the elements present in P are present here, but it is not small. So it is not proper subset, it is just subset. So that kind of set we call simply subset. If it is smaller, for example like this, that is actually the proper subset. In these cases, whether it is not proper subset, we use like this. So P is subset of Q and Q is subset of P, then we say P is equal to Q. This is one important condition, number of times asked in examination in the objective. Now, what can you say about the set n is equal to 1, 2, 3? N is equal to 1, 2, 3, dash, 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 dash. So when you can't say how many elements are there, we put this dash, 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 dash. That means the number of elements in it are unlimited. You can't write, you can't count. Such kind of sets are called infinite sets. Infinite. So they are not limited, but they are unlimited. When the number of elements are not countable, not possible to count, they are not limited, they are unlimited, then we call that kind of set as infinite set. So now what can you say about n? N is an infinite set. That's it. If the set has limited number of elements which we can count, then that kind of set is called a finite set. Many times we write finite sets, and of course some sets are infinite too. Now coming to the last problem, using Venn diagram verify that n of A union B is equal to n of A plus n of B minus n of A intersection B. So this is fact and it has to be verified using Venn diagram. So what is given? A is equal to 1, 2, 3, 4, 5. B is equal to 2, 3, 6, 7, 9. Now A intersection B is equal to 2, 3. A union B is equal to 1, 2, 3, 4, 5, 6, 7, 9. Now because he has asked us to prove it using Venn diagram, let us draw a Venn diagram for this. It should be closed universal set. Now A and B have some joint, so they have to be drawn jointly. So this is A and this is B. Now let us indicate the common elements 2 and 3 in common. 2 and 3 in common. Now leaving these two, 1, 4, 5 here, 1, 4, 5, and here 6, 7, 9. So altogether in A union B, these should be there. So 1, 2, 3, 4, 5, 6, 7, 9. 1, 2, 3, 4, 5, 6, 7, 9. So this is done. Now, how many elements are present in A? 5. So n of A is equal to 5. How many elements are present in B? 1, 2, 3, 4, 5. So these are counted under both. So n of B is equal to 5. Now n of A union B is equal to how much? A union B means all together, united together. So all these, let us count. 1, 2, 3, 4, 5, 6, 7, 8. So it is 8. Now n of A intersection B is how much? 1, 2. Why am I counting all these and writing? Because it is asked to prove that this is equal to this plus this minus this one. So this one we found out, this one, and this one. Everything is found out. Now let us verify it. So it has to be verified like this. N of A union B is equal to N of A plus N of B minus N of A intersection B. So N of A union B as per Venn diagram is 8 is equal to N of A 5 plus N of B 5 minus N of A intersection B is 2. So 8 is equal to 10 minus 2, that is equal to 8. 8 is equal to 8. LHS is equal to RHS, hence it is proved. So how this formula comes and works, let us see. When you are counting all the elements, because this is Venn diagram, you can count in all. 1, 2, 3, 4, 5, 6, 7, 8. But if you take set wise, in set A, we have 1, 2, 3, 4 and 5. So these are the elements we have in A. In B we have 2, 3, 6, 7, 9. So in respect of B we have these 5. In respect of A these 5 we have. And these 2 and 3 are counted twice. So once they have to be subtracted. So that is why, what is this part? It is intersection part. So we are subtracting it. So elements in A and elements in B to be combined. Then from this N of A intersection B has to be subtracted. So this is verified.